What's up guys, Novanoid here, and in today's video, I'm going to be giving you guys a coding lesson. Second part, finally. So we are jumping right back into it. So in my last video, I asked you guys to make a simple calculator, takes in two numbers, and then outputs it. And today you'll notice I'm working in Visual Studio Code. You can remain working on the online version, though I do recommend you try a local compiler because it is definitely advantageous to use one. So we're going to start out and um, type the basic file, main file, um, and this is really all we need to get going. Um, Using namespace std will um, make things a little bit more simple for us as we're newbies programming. Um, and so now you may notice that your solution is going to be different than the one I'm about to code. And it's fine. There's a lot of ways to arrive at one solution. So we're gonna do cout, and we're gonna say enter the first number. Okay, we're gonna create int num1, num2, and just for the sake of this, output, or more appropriately, sum. And honestly, for convention, x, y is fine. And then we're gonna do cin x, and then I'm gonna do cout, enter the second number, cin y, and then we can calculate the sum. Sum equals x plus y, and we can add a comment here saying this calculates the sum, and then we can jump down here and print the result. And there we go. And then we can compile this, and if you're following along at home, I advise setting up G++ compiler, GCC, Clang. These are the most common ones, and they'll be very useful. And you can follow this tutorial to a T with it. So we're gonna do GCC, and this is in the terminal of the folder. So we're just executing this command in the root of the directory that we're in. So gcc main.cpp, which is this file name, and we're going to do -o a.exe, and that's just saying to output the compiled program into a file called a.exe. So now when I do this, it's not going to work because G++. Alright, I don't know why that wasn't working. I think I have a linking error in that, but anyway. So we can run this by doing .\a, and now it's asking us to enter the first number. We can do 3, 5, and it outputs 8. So as you can see, we just completed the homework. And like I said, there's many ways you could have accomplished this. Um, a calculator is the most basic function of the computer. Um, you can think of computers sort of as like just like literally an f of n function. They take data in, a vector of data in, and spit it out. So the computer is taking vector of data in. It might have some data already in here, down here somewhere, and messes around with the data, but it spits it out somewhere. It takes data in, spits it out. That's all it does. Awesome diagram there, I know. So if you're interested, try and expand upon this. And that's kind of what I'm gonna have you do for your homework for this assignment. Here we have the if statement. So the if statement executes code within the if statement, within the block, if and only if the condition in the parentheses evaluates to be true. The condition in parentheses will always be evaluated as a boolean expression. And this is pretty relevant because if you put an integer in there, as long as the integer is not 0, I'm pretty sure it evaluates to be true. So even if it's like -1, as long as something's there that isn't 0, it's probably going to evaluate to be true. And this can get confusing at times if you're new to programming. So for example, if true will always run. So this statement will always be executed. Now instead of doing if true, we can replace um, the condition in parentheses with a more advanced condition that can include variables and conditionals. So here we have a variable, such as an integer. If it's greater than or equal to 3, then we're going to print this if statement. And so if the variable is 3 to infinity, this statement will execute. And then preceding the if statement can be an else if statement. Um, and this code block will only be evaluated if and only if all the previous if/else if statements have been evaluated to false. So for example, if I had an if statement and then had an else if statement after it, if this if statement evaluated to be true, this wouldn't even be checked. The condition in this code block wouldn't even be checked. It would short circuit evaluate. That's what it's called. It would just jump and skip past this. So this works in the same exact way as a if statement does, but like I said, it only gets evaluated if all the previous if statements were false. And then again, there is an else code block. So there's an if, else if, else. And the else code block will execute after all if and else if statements have executed and evaluated to false. And here's an example from a game engine that I'm programming. So if path.empty, so that's a function that's returning a boolean. So if the path is empty, this code will execute and will return. And otherwise, we're going to jump down here and you can notice there's an if statement inside this else. So you can have a lot of branching conditions. Um, and you can see how quickly this can become and create complicated code. So you're going to need some basic Boolean logic to be good at computing. So bools are true or false. 0 is often used to represent false, 1 to represent 2. Since computers are based on only transistors, and they're all either on a state of on or off, which is 1 or 0, true or false, you can probably understand why this is extremely important in math within computer science. Um, and boolean equals is double equals in C++. And this is because if you put a single equals, the compiler thinks you're trying to assign a variable instead of evaluate a boolean expression. So here are the basic boolean logic gates. You'll notice over here there's a lot of complicated ones, goofy ones. You don't really need to know all those right now, but these are the main ones you need to know. And basically says if this and that are true, then and will evaluate to be true. So here we have a truth table. So this is false, false, and the result of the and is false. This is false, true, and you can see the result is false. True, false, false. True, true, true. So the only time an and statement will evaluate to be true is if both the Boolean variables between the and statement are um, are true. So then we have the or statement, which you can see the truth table and the inverter. And the inverter just takes any logic value and inverts it. So if we have a 1, it'll change it to a 0. If we have a 0, it'll change it to a 1. And then how you're going to use these in C++. To invert a Boolean expression, you use the exclamation mark. So you'd use exclamation mark true to evaluate to false. And obviously that's redundant, but that's just an example. And to use and, you're going to use two and signs. True and false will evaluate to false. To use or, use these vertical symbols, and then little error there. True or false will evaluate to be true because true or false is true. You can go back in here and see in OR gate. True or false would be this, so that evaluates to be true. And you might wonder why we use double and double lines for the or. And this is because these other characters perform the same logical operators, but on a bitwise level. So you're probably not going to use that unless you're programming embedded firmware or like low-level programming. But you can definitely see it, and I'll show it to you eventually. So our project. Our project is going to be, we're going to create a basic calculator. And so we're just going to completely get rid of this. And we're going to store int xy, except we're going to use double because we want floating point precision. And now, so I want to have this calculator have addition and subtraction. So a character. So we're going to have a character input equals yeah, we don't really need to start it yet. So we can just have input character, and then we can do cn input, and we're going to take in that character, and now we can do some logic on that character. So if the user enters 1, that character will become 1. And if the user enters 2, that character will become 2. So we can use if statements to compare those characters. So if input equals the character 1, then we want to perform the um, the tasks of addition. And then else if input equals 2. And also, in case you're wondering, this evaluates to be true. You don't, a lot of, a common mistake a lot of programmers do is they'll be like, um, they'll take in some function. So maybe like t, let's just say foo, because that's an example a lot of people use, foo. And calling this function might return a boolean that is true. And they'll do equals true. This is redundant because if this is going to return true and you're just checking to see if this is true before doing this expression or evaluating this, it's extra redundant because this does the same thing as this. So yeah. But yeah, that's it's a little tidbit that might be relevant. And then we're going to have an else statement here for if the user doesn't enter 1 or 2. And we're going to say cout invalid entry. Invalid entry. And then, yeah. So now if the input is 1, we're going to prompt the user for cout enter first number cnx sorry, cout, and then we're gonna do the sum is x plus y. There we go. And now we can just copy this, paste it in there, and do x minus y. And you can see that this gets evaluated the same way it would be if I created a new variable. Because what the code will actually do is it'll sort of create a temporary variable. So we'll get into it more later, but all of these are operators are actually functions in C++ that you can override and overload, which is really interesting and nice. So now we can run this. We have to compile it again and then run it. And we're going to enter 3. Invalid entry. So we're seeing that when I enter 3, it takes in the character input and it checks that it's not equal to 1. So then it jumps here and it'll check not equal to 2, and then it just prints this. So now if I go up and do 1, enter a first number, it's going to jump into this one, and we're going to do 1, 2, and 2, and it's going to enter the sum of 4. So when I entered 1, it jumped into this if statement, and we are entering numbers to add. And then if I do the same thing, enter 2 for subtraction, we take 10 minus 1. Sum is 9, it said, because I copied this code, but the difference should be difference. So yeah, uh, that's a basic calculator using if statements. And what I want you to do for homework is I want you to take this and expand upon it. I want you to add addition, multiplication, subtraction, division, maybe more, but just um, just expand upon it and add some features. So yeah, I'll be back with part 3 in another, I don't know, hopefully not as long. All right, bye bye.